Alright guys, welcome on in. Actually, so I recorded this video and I posted it, and it looks like I got an email about 2 days ago. Much like you guys, I've been enjoying my time off and I have not thought about work once for the past 3 days, which turned out to be a bad thing. So about 2 days ago, I think on Saturday, sometime in the afternoon, apparently my video for this review got taken down. I don't know how many of you guys watched it before then. Hopefully, anybody that needed it. For anybody doing last minute studying, this will help. But yeah, it got taken down for something or another. So apparently, I violated terms of service somehow. My guess is that it was music that was playing in the background. Don't know why they didn't flag my other stuff, but yeah. So this one, we're gonna be going in complete silence in the house, and the only thing to accompany us is the sound of the rain outside my window. Anywho, I'm going to do a shortened review. I'm not going to cover all of our triangle congruence theorems like I did in the first recording, just because it makes the video a little too long, and I need to get to my lesson plan. So we're going to skip that. I'm going to talk about the two types of proofs that you need to be able to do, and then the midpoint and distance formula. So we'll cover those three things really, really quickly, and you just have to go and do triangle congruence on your own. I'm going to include a link in the description below. So if you just take a look down below, there should be a link to general description of the four theories that we're talking about. Hypotenuse leg theorem, you can go ahead and skip. All right, so let's go ahead and start with just the two proofs that I'm going to have you guys memorize or understand one or the other. So I'm going to split this page in two. And you're either going to get proofs for this one. Pretend those are equal. It's not the best drawing in the world, but that's okay. Or proofs for this one. All right, we'll call this A, B, C, D. And we'll call this, I don't know, E, F, G, H, I. All right, and you have to remember a couple things. So each of these will look really, really similar in a lot of different parts. So the parts that look similar are as follows. First off, they're going to give a theorem. So first off, you have to know your triangle congruence theorem. So let's say that I'm going to make this one side, side, side. And then let's say I'm going to make this one side, angle, side. Okay? And you'll have to be able to know, or I'll tell you that this is the theorem that we're using. I'll tell you, yeah, on the test, I'm sorry. On the test, it tells you that this is congruent by side, side, side theorem. So what is missing in the proof? So I'll show you how it looks in a second. I'm going to show you the version with the blank, and then I'm going to show you exactly what you have to do. Okay? So it'll say something like, let's see, AB is like that, like that, like that. It'll look like that. Okay? And then your first statement will be that side AB, or line AB, is congruent to CD. And we know that. All right, remember these are statements on the left, and then reasons on the right. Okay, I guess I should have made that a dashed line. Whatever. In any case, so AB, the side on the left, is congruent to the side on the right. The reason is given. Okay, you see those little dashes, those little lines in there? Those mean that the problem gives that information to you. It also gives one more piece of information to you, and your first job in every single proof is to label your givens. So we know CD is the same as AB because of these little lines. You'll notice that there are other little lines right here and here. So that must mean that these two sides are equal. So you have to be able to name these. So I would put something like AD is congruent to, and then I would include a blank here. Okay? And you'll have to fill in that blank. So you would put, all right, well, AD is the same as this top part, so it must be, if I went AD, it must be the same as BC, so you'd plug in BC here. And then maybe I'd also leave a blank here and ask for the reason why, and you would put given. Okay? Now that you've stated your two givens in both of these proofs, you're going to be given two different givens, and after you've labeled your givens, here's the third part. You're going to get a third part, and it's going to say that AC is the same. So line AC is the same as itself. And, and you would say, same line. Same line. There are lots of different ways to word reasons. You could have written this a little differently. If you wanted to use a congruent sign, you could have. I just used equals because it's the same line. So I will accept any of those answers. Same line. Same side would work here too, but this is typically what you want to put. Now that you know that this side is equal to that side is equal to that side, and then this side is shared between the two, you just have a fourth condition. So triangle, and let's go ahead and name our triangles. So ABC is congruent to triangle, so ABC, and then you go ADC. And then, I would maybe put another blank right here. And you'd have to be like, all right, well, what's the reason? The reason is because they share side, side, side. So because they share side, 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 they must be congruent. Remember, all those things that you learned, side, 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 angle, angle, side, angle, side, angle, those are all triangle congruence theorem. So if they share those three things, they are congruent. So this is what you'd look for with this, okay? And remember that all of your square shape pairs of triangles are going to share that line here. So you know automatically that there has to be a side, okay? There must be S somewhere in there. So it's going to be side, 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 angle, side, whatever, whatever, okay? But it has to have a side. All right, next one. So we're going to do much the same thing over here. And this one I told you is going to share side, angle, side. Okay. So if it shares side, angle, side, let's go ahead. Statements, reasons. I'm going to shorten all of this. All right. And I'm going to give you a couple things again. So I'm going to give you, I don't know, let's give you that. The same as that. And then that and that. There we go. All right. And let's go ahead and start with what they give us. So they gave us these two little dash parts and these two little curve parts. Remember, the lines are called sides and these curves are called angles. So we know we share an angle and a side. There's something else you have to know. Just like in the first one, you have to memorize that you always have the same line in the middle there of that box. Here we share this part, okay? So that's something you have to remember. That is really small. I should have drawn that bigger. That's okay. So you have to remember that you share these angles here, and that's the opposite angle theorem. When they're on opposite sides of a vertex like this, you share those angles. So if this angle is 30, that angle would also be 30, etc., etc. Okay? So we know now that we share an angle, a side, and an angle. I'm so sorry. I drew the wrong type of example, angle, side, angle. So we'll make this one angle, side, angle. Okay, and the problem would tell you this, and hopefully I didn't screw up my drawings. I'll have to go check that after this. But yes, so angle, side, angle. What you want to name first are the two givens. So let's name our givens. So let's name first our angle. So angle F is the same as angle I. So again, I would give you a blank. I would put this little sign. I'd say angle I. And then you'd have to go, all right, well, angle F is the same as angle I. What's the reason? Given. All right, your first two reasons are always going to be given. So you already know the second one's also going to be given. But let's say what the second one is. So your first thing was an angle. The second thing should be a side. So let's find out what sides are the same. Side FG, because that little dash, and side GI, or IG rather. So FG. Oh, all right, well, let's pretend there was a blank there. Congruent to side, what did I say, IG, IG. Okay, and that's also a given. So now that we have our two givens, all right, we had two givens. The next one followed this interesting part where it changed. It became same line. Well, I told you, just like you had to memorize that middle part here in this one, in these bow tie shapes, there's also going to be these shared angles, okay? These shared angles. And again, that is because of opposite angle theorem. So let's say I put a blank there. I was like, well, why? What you'd have to put is opposite angle theorem. Okay. Or you could just put opposite angles. I would accept that as an answer. And after you've put opposite angle theorem, let's say there was another blank here. And then congruent. And I said that angle FGE you'd have to tell me that angle FGE is the same as HGI. Yep. Angle HGI. That's because of the opposite angle theorem. So now you know that these triangles are congruent. So the triangles FGE is congruent to the triangle HGI. And the reason is, so let's say there's another blank, it would be ASA. Okay? And you could write ASA theorem or something if you wanted to. But that is how to deal with the proofs that are going to be on this test. Now remember, it won't just be ASA, it won't just be SSS, but these should look the same no matter what. For all of your rectangular shaped triangle theorems, it's going to be given, same line, SSS. Given, same line, and then one of your triangle theorems. And then over here, for these bow ties, it'll be given, opposite angle theorem, and then one of your theorems, which I give you on the test. So I give you what it is. So this one might say, I don't know, it might even say ASA. So at the end, you would just put ASA instead. Okay? So it just depends. You just have to fill in the blanks. And be able to name your sides. So the trick on this left part is to be able to name like angles and sides. Remember, angles are named by the letter next to them, or a combination of 3 letters. So I could have also called this GFE. And then lines are named by the 2 letters. So FG is that line, FE is that line. Just look for the 2 letters at the end of your line. Look at your line, look at one end, so that's H, that's an I, so that line there must be line HI or IH. Doesn't really matter which one. Okay? So that's proofs on this test. That's proofs on this test. Go ahead and rewind if you need. All right. Beyond that, we did midpoint and distance formula, and these are the last 2 I'm going to cover on this video real quick. That way I can get it up for you guys that are doing your last minute studying. So let's talk about distance formula first. Distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This is also equivalent to the Pythagorean theorem, even though it might not seem that way. So a squared plus b squared equals c squared. All right, and you're going to get a couple of different types of examples. I'm going to do 2. There are going to be 2 types to show up on the test, okay? So we'll do the first one in black, the second one in red, and I'm going to use one of them. So the Pythagorean theorem one I'm going to do in red, okay? You're going to get an easier example where it goes find the distance. So find distance between 2 points, and it's going to give you some points like, I don't know, find the distance between 0, 1 and 2, 5. Okay, so find the distance between those 2 points, and what you're going to do is you could just graph it. All right, so let's go ahead and make a quick graph. So I'm going to use this half of the page here, and we're just going to make a graph. So 0, 1, 0, oops, sorry, you can't say that, 0, and then go up 1 spot right there, plot our dot, and then 2, 5, so 1, 2, 1, 2, 3, 4, 5. We'll extend the graph a bit, place our dot, draw our line, oh. And what you'll notice here is that it forms a triangle. Okay, I'm going to use black to separate this out, but it forms a triangle, and you can figure out how long the sides are of this triangle. So it went over 1 spot, 2 spots, so it's 2 horizontally, and then it's 1, 2, 3, 4 spots up. In which case now I can use Pythagorean theorem to find the third side. So a squared plus b squared is going to equal whatever this is. So let's find out what that is. So a squared, 2 squared, plus b squared is 4 squared equals c squared. And then 2 squared is 4. 4 squared is 16. And then equals c squared. We'll just continue to finish this out. And remember, you guys might want a calculator for this. That said, if you don't have a calculator, you can. Remember, the opposite of squaring something is the square root. So we're going to take the square root of both sides. If you don't have a calculator, you can leave your answer here for now. I highly recommend that you have a calculator, because then you type this in, you'll get a decimal, you'll get like 4.5 or 4.6-ish. So you would put that decimal there. So you would say that C is equal to like 4.5. I'm not really sure exactly what it is, so I'm just going to put this question mark here. On your test, please don't put a question mark. Just put the actual decimal. I don't know what it is off the top of my head. I don't feel like going to get a calculator. So that's how to find distance using Pythagorean theorem. Something we're already used to. It's something we've already done. But let's do distance with the distance formula. And now, it really doesn't make a difference which one you use. In fact, we're going to do the same problem, but we're going to use distance formula instead. Typically, the reason why distance formula is a little bit more useful is because using this, you can apply really big and really ugly numbers much quicker. It's just hard to graph points like 0, 30 and negative 20, 55. That just sucks to graph. It's not impossible, you can estimate and whatnot, but I don't like graphing big numbers, so that's why this formula is a little bit more all applicable. This is pretty easy to understand for smaller numbers. In any case, let's go ahead and do the same problem. All right, so find distance of 0, 1 and 2, 5. Again, we're not going to do this graph. Instead, you're going to call them, all right, I'm going to call this one on the left. I'm going to call this point 1. I'm going to call this one point 2. Okay? And remember, every point has an x and a y, so there's x1, y1, x2, y2. And then we're just going to plug it in for the formula. So d is equal to the square root of x2 minus x1. So it's 2 minus 0 squared. And then y2 minus y1, so y2 minus y1, 5 minus 1 squared. Don't forget your plus sign between these. And then let's go ahead and do the math. D is equal to 2 minus 0 is 2, 2 squared is 4. 5 minus 1 is 4, 4 squared is 16. And again, D is equal to the square root of 20. And you'll notice they work out exactly the same. All right, and then of course you can say D is roughly equal to like 4.5-ish. But they work out exactly the same. You just avoid having to do a graph with this second version. Okay? So either you get used to graphing and use your Pythagorean theorem, or you get used to memorizing the distance formula. It does not matter to me which one you'll have. These could show up in a word problem. Okay, so an example of a word problem looks like this. Sorry, that's some old work. A word problem could look like, Sam drives 8 miles east and 4 miles west to the nearest McDonald's. To the nearest. I don't know. I don't want to go to McDonald's. I want to go to like Checkers. I haven't seen. That's a G. That's a restaurant that starts with a G. I don't know why I started writing a G. Grill House. Okay. So Sam drives 8 miles east and 4 miles west to the nearest grill house. If Sam took the shortest route how far would she have gone? Okay, Sam took the shortest route, how far would she have gone? So again, we can just draw our little triangle. Okay, I'll draw it on this page. Let me just pull this up a little bit. You guys can start to see a little bit better. All right, so 8 miles east, so remember your compass. My gosh, you guys really should memorize this, by the way. Okay, so you guys should really start to memorize your cardinal directions. They're kind of important in life, but that's okay. On the test, I will include a compass up at the top somewhere. So 8 miles east, so start from a starting dot. Okay, go east 8 miles. And you can estimate, I just put a random distance. And then don't do west, sorry. That doesn't create a triangle, that just makes you go back, so it doesn't make any sense. South. Okay, so south means down, so we'll go down 4 miles. So here's grill house, and then here's you. So if you had gone the shortest distance, you'll notice it creates a triangle. So then we do our Pythagorean theorem. So, 8 squared plus 4 squared equals c squared. And we'd finish out the problem. Okay? Using the same method we did earlier. If you wanted to use points, you could use 0, comma 0. And then remember it went to the right 8. So it's 8, comma, down 4. Down 4 means a negative 4. So you could have also used 0, 0, and 8, negative 4. It's up to you. It doesn't really matter whether or not you use Pythagorean theorem or distance formula. Like I said, it's exactly the same. So you will get problems like this. All right? Now, midpoint formula. Midpoint formula is actually a lot easier. All right, so midpoint formula, midpoint. Midpoint's this. Remember, everything has an x and a y, so the midpoint is just asking you for a point. That's why it's called the midpoint. All right, so to get your midpoint, you're going to take x2 plus x1 and divide by 2, comma y2 plus y1 divided by 2. And this is going to give you a point. Basically, you have to remember your x's, add them together and cut them in half. Your y's, add them together and cut them in half. Another way to think of the midpoint formula is to think of the average of the two distances. Okay? So, let's go ahead and give you any 2 points. I'm going to give you, in fact, let's find the midpoint of these points that we did here. 0, 1, and 2, comma 5. 0, 1, 2, comma 5. And remember, we labeled this point 1, point 2, and then we said, all right, well, this is x1, y1, x2, y2. And let's just plug them in. So add our x's together, 0 plus 2. And then add our y's together, 5 plus 1. And yes, you can absolutely shorten this by putting all of your steps together. You definitely don't need to write out everything like I am, but that's up to you. 0 plus 2 is 2, divided by 2. And then 5 plus 1 is 6, divided by 2. 2 divided by 2 is 1. Make sure you simplify at the end if you can, okay? If it's simplifiable, 6 divided by 2 is 3. If it's simplifiable, make sure to give me that simplified answer. 1 comma 3 looks a lot prettier than 2 over 2 comma 6 over 2. All right? And that is midpoint formula. That's all it is. So you just have to memorize this formula and then your distance formula, or do Pythagorean theorem for everything. Okay? That's midpoint formula. You will not get any word problems from midpoint formula just because I didn't give you any examples of word problems with midpoint formula. I don't think, at least. I don't know if I did, but I didn't include them on the test, and I didn't really think about doing a word problem with midpoint formula. So luckily for you guys, you lucked out. Either I didn't teach it to you, or I just didn't think about it. But regardless, I'm not going to change the test at this point. So that covers everything other than your triangle congruence theorems. Again, I will include a link down in the description below that will take you to a triangle congruence page where you can where you can read about your different triangle congruence theorems. You can always just YouTube a triangle congruence like tutorial video. Those are pretty useful. Khan Academy is really great. So yeah, in any case, best of luck. I hope you all do really well on your quiz and or test. Or rather, I'm so sorry, you all do well in your test. And I will see you guys tomorrow. Bye guys, hope you had a good weekend. Ciao.